Let's implement Leetcode 129. Given the root node of a binary tree, with each node having a value from 0 to 9, we're asked to return the sum of all paths from the roots to the leaves. Now, in addition to having an integer value, each node has a pointer to its left child and a pointer to its right child, which are both null by default. So the leaf nodes in this tree implicitly have both their left and right pointers as null. At a high level, we'll need to traverse or visit every node in the binary tree, starting at the root node. Secondly, as we traverse the binary tree, we need to keep track of every node along the current path. So let's declare a double-ended queue to keep track of this. A dequeue allows us to add and remove elements from both ends. At the end of each path, we'll convert the queue into a number and add it to the sum. So let's declare variables for these. Finally, we'll need to backtrack by removing the last element from the queue before exploring a new path. After the traverse method is done, we'll return the accumulated sum. Now let's implement the traverse method. The traverse method is initially called on the root node. If the node is not null, we add it to the queue. Next, we recursively call traverse on its left child, and now we are at the 5 node. We add 5 to the queue and call traverse on its left child, which is the 2 node. 2 is a leaf node because both its pointers are null, so we'll convert the queue into a number and add it to the sum. Finally, we'll backtrack by removing the last value from the queue and returning. We're back at the 5, so next, we'll recursively call traverse on its right child. 7 gets added to the queue. It's a leaf node, so we convert the queue to a number and add it to sum. We backtrack by removing 7 from the queue and returning. We're done with the 5 node, so we backtrack by removing it from the queue before implicitly returning. Next, we call traverse on the 1 node's right child. 0 is added to the queue and 10 is added to the sum. Finally, 0 and 1 are removed from the queue and the final sum of 319 is returned. Assuming a balanced binary tree, the space complexity is log n and the time complexity is n log n.